for example, to bring to your attention that unfortunately, most of our colleague engineers, civil and structural, are in their opinion able to identify and recommend the right solution for the foundation types and the soil treatment, ignoring the importance of the presence of a certified, qualified geotechnical engineer to help them in their, for example, projects. That's why, for example, uh, the majority of the consultant firms worldwide, they have almost all disciplines except the geotechnical engineering. They give importance, for example, to the MAB more than, for example, the geotechnical. And civil engineers, structural engineer, unfortunately, we are all origin structural and civil engineers, prefer to take the lead and replace the geotechnical engineers. So the description of risks and hazards in this webinar is intended to engineers for further investigation of the risks and hazards in their area of interest, such as a site for a home, community, road, or schools, locating facilities in areas with extensive risks contributes to loss of life, health, and properties. As you see, for example, some photos here in this slide are self-explanatory. No need to explain to which degree or level of risks reached this home. The settlement exceeded all expectations, and you know very well that always in the design we are talking about 25 millimeter, 50 millimeter, but here we reached meters. I mean meters, not only 1 meter, in some locations reached 3 meters. So limitation of soil survey, on most cases, consultant firms rely on what, for example, the laboratories recommend them to do, for example. They limit their investigation to doing, for example, boreholes or CBT or trial bit with some routine tests, like, for example, sieve analysis, uh, Atterberg limits, chloride, sulfate, pH, somehow like this, ignoring, for example, the hazardous material like environmental contamination, organic, carbonate, gypsum, etc. So the soil survey does not answer or address all of the concerns, but it does address many of them, or can lead to an understanding of the relationships. That's what happened, for example. See, for example, these results, the combination, the interpretation of the geotechnical and the geophysical together. This is the geophysical. This is the calibration with a borehole, identifying the same hazards encountered in the geophysical. That's why, for example, engineers rely on what the SVT giving them blindly without uh, interpreting the results properly and see the samples and the description, etc. Because here the SVT, if give high SVT on the gypsum, what does mean? This is irreliable, and we cannot, for example, build on. But unfortunately, most of the labs or the engineering offices rely on this and say, okay, we have dense, very dense, for example, or hard, very hard, for example, strata, so we can build on it. Soil survey are limited by the chemical and physical data that are collected. And most of the laboratories focus on the physical and the routine chemical, ignoring, for example, the non-routine tests like, for example, TSS, TDS, carbonate, organic, gypsum, etc. What does the engineer needs to know to make the right assessment? In addition to technical knowledge, an engineer should have experience in conducting geotechnical and structural assessment, as well as the ability to analyze complex data and communicate findings and recommendations to stakeholders effectively. See here, for example, why we reached this level of distortion or of failure, like infrastructure and building. Because the engineer who interpret the results and recommend the type of foundation was, was not aware, for example, about the subsurface hazards encountered during the soil investigation. And he gave recommendation for CBR certain value, for example, bearing capacity certain value, and in the short term, both structure and infrastructure reached a level of failure, cannot make any repair with, and we shall demolish everything and reconstruct from zero, especially for this road. For geotechnical assessment, an engineer needs to have a deep understanding of soil mechanics and foundation engineering. They should be able to conduct a comprehensive site investigation to understand the subsurface conditions and the properties of the soil or rock that supports the building. They should also have knowledge of various types of foundation systems, such as shallow and deep foundations, and the factors that affect their performance. In terms of the type of test needed for an evaluation, multiple types of tests are typically required to get a comprehensive building geotechnical characteristics. For example, going to a site, for example, where you have a problem, it's not enough to, for example, do borehole and rely on what you get from the borehole. You have to go there and make the visual inspection and take all the notes, all, for example, the defects to be recorded, and try to understand from the original soil report what is there, what's the recommendation done for this. Then, for example, he will decide whether he will do routine and routine tests. For example, if you have, for example, leakages from the sewage, so in this case, how you can identify? You have to make some environmental test to identify the, for example, the nature of the water contaminated the soil. Then, for example, identify the source of this problem and fix it before, for example, doing any rehabilitation to the building. So as we told, for example, and introduced, for example, geohazard, we will talk, for example, geohazard, we have a lot, for example, we have organic, we have clay, we have etc. But here, in our cases, on our presentation of today, we will talk about the gypsum in excess and calcium carbonate in excess, because these two materials are very dangerous to the structure and infrastructure. Gypsum, as you know, is the most common sulfate mineral in soils. Gypsum in soils generally is an evaporite. It is mobile when dissolved in water and deposited in the soil or on the soil as the water evaporates. I can give you an example, and I will show you this, for example, in the case studies. that, for example, some of consultant firms or specialists saying, okay, if the problem coming, for example, on the upper, for example, 4 or 5 meters, let's, for example, make a replacement and replace this soil by, for example, suitable soil for as a filling. But with time, in the short term, the soil again becoming loose and subsidences appear to the surface. Why? Because the gypsum, as we told, is a dissolvable material and evaporated and circulated in between the soil particles with the water and loosening the soil again and creating a problem for the structure and infrastructure. Gypsum primarily occurs in soils of the arid parts of the world, like, but not limited to, the GCC countries, where, for example, this appeared everywhere. These soils generally are in areas where the parent material is high in content of sulfates. For this, for example, point number 2 or this bullet, I will show you, for example, a section of this one. You see, this is the parent materials where, for example, the gypsum dominated, and always, for example, whatever you do in the subsurface upper layers, replacement or improvement, etc., this material again come and, for example, destroy the structure of the soil on the top. So from where the origin of the gypsum coming? From the mother formation. We'll talk about it a little bit. Gypsum is somewhat soluble, so it has several undesirable effects. Excess water, such as runoff water from a roof eave, can dissolve soil around the base of a house. Irrigation in areas with gypsum also can result in dissolution. I met, for example, a case in during our works in some of the projects, a residential villa erected in 2 piles, but part of the villa subjected to severe damage, and the client or the owner of this building saying, why my villa erected in 2 piles and I have this, for example, severe damage in this part of the building? When we investigated this, we found that he used the CFA piles to support the building, and he, for example, bid or embed these piles into the gypsum layer, and he is using irrigation sweet water all around the building, which, for example, dissolve the gypsum around and the pile, and also at the two of the pile. Then the pile settled freely without any resistance from the soil. This is a case which we met in or encountered in our, for example, investigation for damaging buildings. Gypsum is corrosive to concrete. Also, gypsum is a dangerous material to concrete. Soil high in content of gypsum requires special cement, special treatment, or density enhancement. The ions in gypsum react with the cement and weaken the concrete. Associated sulfates, such as sodium sulfate and magnesium sulfate, also contribute to the deterioration of concrete. Corrosion of concrete is most likely to occur in soils that have more than about 1% gypsum and are in areas where, for example, the gypsum dominated. For example, gypsum, some author, for example, saying that, for example, soil with more than 10% gypsum may collapse if the gypsum is removed by percolating water. Even areas of low rainfall can receive enough extra water to cause problems in these soils. Diverting surface water away from the house and roof gutters and piping runoff away can help to alleviate the problems. According to Alfen and Romero, gypsous soil can be defined as soil that contain more than 2%. And the percentage is very low, but this is creating a hazard. Other author, for example, saying Barzanji classified the soil in two different categories, from 0 to 30 to 0.3% non-gypsous, 0.3 to 3 very slight gypsous, 3 to 10 slightly gypsous, 10 to 25 moderate, 25 to 50 highly gypsous, more than 5, this is very severe. So here, for example, we talked about the mother or the parent formation. For example, here we called, there are, for example, in the GCC, for example, a formation called Gash Saran formation. Gash Saran formation dominated on the majority of the subsurface soil on the parent rocks in the GCC countries. What's the mean of the Gash Saran formation? Is a thick evaporitic basinal succession consisting of carbonates and evaporites with marl and thin limestones after Bahrudi and Kowi. It does not form natural outcrops at surface. However, the dissolution of carbonate and evaporites within this formation causes subsurface voids. The dissolution of this carbonate cause the subsurface voids. We see a case, a real case about this, for example. Even though some voids occurred in non-soluble rocks, we encountered in our investigation, for example, voids in siltstone, sandstone. They were most likely associated with the dissolution of Gash Saran formation underneath. Since the Gash Saran formation is so extensive in, for example, the Abu Dhabi Emirate and some other emirate area soil, and sediment above the Gash Saran formation can migrate down into voids. Focus with me on this, that sediment above, meaning the above layer, can migrate down into voids and fractures of the soluble rocks through suffusion or piping processes. See this case study. During the construction of an internal road in an area in Abu Dhabi, the engineers encounter, for example, a sinkhole. They circle this with the safety barrier and take the coordination, etc. And the engineer decide, okay, this is a sinkhole, appear this on the surface, etc. So fill it with the road base and continue the construction. What's the consequences of this? If this, what we can say, wrong decision during the rainy weather, for example, the water in the area gathered and oriented by the nature to this point. So see the collapse, for example, the infrastructure, part of the residential villas also collapsed, etc. I have other photos, but I will not share, but I can talk about it. That, for example, the contractor coming, bringing, for example, a tank of water around 5,000 gallon, and poured this water nearby the villa to see where is the water, for example, is going. Because all the water here, we're talking about maybe 100 or 1,000 of cubic meter disappeared. So for him, for example, he decided to go with the tank to see whether the water, for example, appear on the surface or not. He didn't see any water coming to the surface, all swallowed by the ground. In place of, for example, solving the problem, he, for example, make the problem worse. See, we did, for example, geophysical survey, and what we detect here, for example, a big layer of extremely low resistive body, which is, for example, like a cavity, okay? And we, for example, once identify this, produce the solution for this by, for example, grouting and control modulus column, etc., to fix the problem. And the problem since 6 or 7 years never, for example, worsen and always in a good conditions. And we did calibration with the boreholes, etc., to make sure that this layer, what is making the problem. So this, as we told, this small sinkhole, which we see here, for example, here, the material immigrated from through, for example, the voids through suffusion or piping process, and for example, creating this sinkhole. So unless you fix the voids in the deep layer, you cannot, for example, fix the problem of the surface sinkhole. Here, for example, I expose, or I, for example, present some, for example, characteristic of gypsum from the literature, just to show you, for example, to which level the gypsum is, for example, strong. Like, for example, the unconfined compressive strength reach 35 megapascal for this kind of gypsum, and the tensile strength up to 3.6 megapascal, and the Schmidt-Haber up to 23 megapascal. This anhydrite, for example, gypsum also, the strength is very high. The most important for this, for example, the dissolution rates of gypsum. Yani see, for example, this is from the literature, for example, saying at Ribbon Parks in North Yorkshire, for example, a large cubic block of gypsum detached itself from gypsum cliff and fell into the river. It measures about 3 meters along each edge and dissolved away completely in about 18 months. The water flow rate passed in, it was about 1 meter per second. Calculations show that approximately 1 meter of gypsum a year can be removed from a gypsum face by a water flow of about 1 meter per second. I will not read all this, but you can, for example, refer to it for more information. But from our, for example, experience in one area where we have service road, for example, they fixed the road 3 times. Then, for example, they decide to remove the uppermost 3 meters and replace them by rock fill. After doing all this, for example, 1, 2 years, 3 years, the road again collapsed. And what was the solution? I will show you what they did. Sorry for this, for example, going directly to this, just to show you. Yeah. See here, for example, the soluble constituent, for example, in this road reaching 89%, and in different layers, and see the samples from the SBT. At the end, for example, when they, for example, they couldn't, for example, fix the problem by the rock fill, they decide to go with piles and the slab on top. We'll talk about this. This is just to show you the degree of, for example, or the level of risk to which, for example, reach this infrastructure. So the second materials in which we can talking about is the calcium carbonate in excess. Calcareous sand formations are considered problematic due to their possible crushability and high compressibility. Carbonate sands differ from terrestrial sands in at least two important respects. The particles are primarily of biological origin and consequently are relatively soft and easily crushable. Cementation may be present with the deposits, but is frequently weak and almost random, with cemented and uncemented layers occurring within short distance. So H.G. Poulos and others concluded that significant settlement can occur in calcareous sands, which are inherently more compressible than normal silica sands. Now, for example, a day, some consultant saying, okay, we got, for example, dense to medium dense, and sometimes very dense, for example, sandy soil. So we can, for example, get a building capacity of, for example, 100 kilopascal, and we can build on our, for example, superstructure, and we don't need more than 100 kilopascal, ignoring, for example, the presence of these materials, even, for example, reaching maybe 90%, and saying, no, it's okay, no issue about this. After, for example, certain years, not reaching even 5 years, the superstructure foundation failed to support the structure, and the structure in general failed to stand up. So carbonate sediments can be cemented to various degrees. The degree of cementation can vary over entire stratigraphy interval of a particular formation. And on a smaller scale, variability can be high even within the dimension of the average laboratory site specimen. Variability of cementation results in material with a wide range of properties, so that it is difficult to generalize about its effect on engineering behavior. And unfortunately, we are, or in general, engineers use, for example, the normal relationships for the calculation of the bearing capacity, regardless, for example, the presence of such materials. The available data appears to indicate that cementation contributes to the strength only at relatively low level of strength. Destruction of cementation occurs when the apparent over-consolidation pressure is exceeded, or when certain levels of axial strain are exceeded. Kelly et al. Performed odometer test on cemented marine sediments and found that the over-consolidation ratio increased with carbonates content, possibly as a result of increased cementation. They believe that there is some evidence to suggest that the cemented structure of the soil is a transient phenomena which is destroyed with burial, after which the sediments behave as normally consolidated soils. So we cannot rely on such materials and erect our infrastructure without special treatment. The susceptibility of the individual grains of some carbonate soil to crush under relatively low stress has a number of important effects on their engineering behavior. One more thing, for example, I can bring to your attention that recently we did, for example, um, I think around 100 of boreholes in um, around 50 plots or something like this, and we found that the calcium carbonate as CaCO3 exceeded 80% everywhere. And in the top, for example, where we don't have groundwater, the soil dense to very dense. And in the bottom also, in the top of rock, dense to very dense. But in between where we have the fluctuation of water table due to the high and low tide, the SVT value decreased too much, and the soil becoming loose. And the soil becoming loose, which mean that, for example, this material also soluble and dissolvable into the water. See, for example, the case studies, which, as I told you, the most important things in our presentation of today, the case studies. See, for example, this residential. Fortunately, some of them, for example, erected into piles, they don't have problems. The problems appear only where they have, for example, the slab on grade. The slab on grade inside the building, not a suspended slab on grade, settled even, for example, 1 meter or more due to, for example, the dissolution of the subsurface soil. And boundary wall services, for example, buildings, see very light structure, even the soil cannot support this. And by doing, for example, geophysical and geotechnical investigation, we identified this kind of materials. See from the geophysical, here, for example, like there is no materials. And here, for example, see the level of, for example, damages reached in to the building. Certainly, there is no solution for this superstructure, boundary wall, etc. The only things that you demolish and you reconstruct them using, for example, a certain type of foundation with certain, for example, kind of improvement. We will talk about it. This is the infrastructure as well. See here, for example, in this area, the carbonate content, for example, around 50%. And by the way, for example, the gypsum content and the carbonate content depend each on another. For example, if the carbonate is high, for example, the gypsum is low, and vice versa. See, for example, here, from here, for example, we get, for example, in this layer, the SBT 15, 30, and refusal. So the engineer, for example, in saying that, for example, he has a SBT 30, okay, fine. I don't need, for example, more than like this. Okay, give me bearing capacity. I will do my structure, superstructure, etc. on this material. It's not an issue. But in analyzing this and seeing this, for example, that the SBT is, for example, inaccurate test, and the judgment and the special testing is a must for an engineer to identify, for example, the nature of the subsurface soil. If this some testing, and this is after testing, and the percentage of the material encountered there is high. So now, what's the solution for this? Certainly, some of the engineering firms saying, okay, we will do, for example, what we can say, soil replacement. Soil replacement, we can solve the problem. The majority of the engineering firms recommend for soil replacement. But unfortunately, this is inadequate and wrong solution for such materials. And at the end of the presentation, I will show you some of the researchers saying that the best material to deal with such geohazards is the cementitious, for example, soil treatment using, like, for example, geotic grouting or deep soil mixing or other, for example, a controlled modulus column or something like this. See, for example, here, we used the soil mixing in the playground to fix the problem of the excessive settlement, which couldn't, for example, stop with any kind of a treatment like soil replacement. And what we did on top of this, for example, we did, for example, we put, for example, a layer of geotextile on top of the geotextile, a previous material to break the capillarity of the water moving under the ground. And on top of that, for example, we put the geogrid. Then, for example, the tiles. So someone maybe would say, okay, this is very expensive solution, but this is the solution. If you will not do it from the first time, you will pay its cost, for example, 10 times by doing useless repair with time. This is a case study too, for example. Here is the service road. Also, as I told, for example, the engineers ignore the presence of such materials and construct the pavement. But after having this subsidence, we did the investigation. We found, for example, that the carbonate around 60%, and the TSS, total dissolved salts, around 83%. And we took the samples. This is before testing. This is after testing. Another case study is very important. For example, also, this is, for example, a high-rise tower. And here we have a bridge. And here we have a water canal. So what happened? The bridge, for example, itself erected in two piles, while, for example, the ramp erected on strip foundation, shallow foundation. And before the construction and during the construction, the cracks started, for example, to appear into the retaining wall and also in the bridge itself at the level of the ramp. So the client saying, okay, the tower here is, for example, settling and taking with it, for example, the bridge. And doing, for example, this is before constructing, this is during the shoring. This is, for example, the subsidence, the defects, the cracks everywhere. When we, for example, we did the detailed investigation or detailed, for example, assessment referring to the existing soil report and doing some geophysical line, for example, to identify the subsurface soil. We found into the old report that the carbonate content, for example, around minimum 60 and maximum 90% and average 84% up to 17-meter depth underneath the foundation of the ramp. So, which is the root cause of the settlement of the ramp. Why? Because the tower itself erected in two piles, and we had a monitoring system inside the towers, proving that the settlement of the tower is very minimal and not exceeding 3 millimeters. This is the location of the bridge and the tower, and this is the bridge, and this is the canal. Okay. So in doing the geophysical line, for example, all around the bridge, for example, if we see the location here of the lines, here, this is the lines of the geophysical. We found this kind of materials, the very weak soil, very low SBT, and very low shear velocity, which is proof, for example, our interpretation, and confirm the findings from the soil report. And during the design of the bridge, no one paid attention to this kind of hazardous materials, and the consequences is very aggressive, and the bridge continuing settling, and up to date I think they didn't fix it, the problem. Here, for example, townhouses, residential, for example, erected in reclaimed soil where we have the carbonates content, for example, is very high, and also the townhouse is erected into shallow foundations in such materials, and these materials with time crush it, dissolve it, etc. Then, for example, we reach this level of damages into the buildings, and the residents are afraid, for example, to stay safely in this kind of structure. See everywhere, for example, calcareous sand, calcareous sand, calcareous sand, calcareous sand, but unfortunately they didn't do any routine test, non-routine test like carbonates about this calcareous sand to measure the percentage of the calcium carbonate. This also service road in which we talked it before. They didn't pay attention to this. They're replaced by rock fill, etc. Then, for example, at the end, they do piles and the slab on piles around 500-meter length and 60-meter wide. Very expensive solution. See the rock? This is the rock which they used, for example, to replace the upper 3 meters of the soil. This is other, for example, strategic project, for example, the consultant recommend to do the investigation into the pavement to identify the root cause of the problem. So we came as consultant on board for this project, and they told us, for example, how many days we have only 2 months to finish everything, improvement, pavement, everything. So how we can, for example, finish the soil investigation in 5 days? I told them, no, I don't need any, for example, soil investigation for this. Give me the old soil report. I checked the old soil report. I found this kind of materials. The carbonate content percentage is very high. In spite of all the repair which they made, they failed, for example, to fix the problem. Also bring to your attention that, for example, this pavement erected onto, for example, improved soil by stone columns. We'll talk about the inadequacy of the stone columns for such materials. So one of the consultants says stone columns not recommended. I agree with him that, for example, soluble soil will remain below the slab, ongoing volume loss expected. I agree 100% with this consultant, and he said insufficient horizontal soil support of columns due to volume loss and soft soils. Also, I agree with him with this note, because in dissolving these materials in between the columns no more support the lateral force, especially on the pavement where you have movement in all directions. These consultants say jet grouting less recommended. Why? Because a barrier to soluble soil by a jet grouting wall, flexible installation with regard to underground structure, complete soil exchange, no dewatering required, light, etc., etc. But they didn't recommend for this. What he recommend? Continuous auger piles and the slab on piles. But he didn't do this as a structure, purely structure. But he told that, for example, part of this slab can be, for example, supported into this subsurface soil. But with time, the slab also broken. So we came aboard. In interpreting the results, as I told you, I didn't do any soil investigation. I told, okay, whatever you have, I can rely on it. I will do two things, jet grouting and control modulus column, depend, for example, on the availability of each of them. Or if both are available, we will do both. So we took a grid of 1.5 between point to point, center to center, and up to the hard strata, the top of the rock. And on the top of that, for example, we put, for example, a layer of geotextile, then a previous layer, then, for example, a geogrid layer, then a road base layer, then geogrid layer, then, for example, the pavement erection. Why we did like this? Because the criteria of settlement, they need only 3 millimeter on 4 meter, yani meaning less than, for example, 0.001 degree. So the project had 100% successful and zero settlement after 3-4 years. So the mitigation measures a strict groundwater management, because the enemy of this subsurface soil is the water. Alternative method of irrigation, or even don't do any irrigation in the area where you have these subsidences. And one of the customers or the client, I visited his building, he told me, really, my friends and family, etc., relatives who are living in the same area, they didn't, for example, do any kind of irrigation or any kind of, for example, green area. They use artificial green carpets, and they're building in perfect conditions, except me, because I did, for example, real landscaping, and see what happened to my building. So an adequate system for draining shall be considered to avoid the removal of gypsum, salts, or cementitious agent from a section in the soil profile. The dewatering program should be designed by a contractor experienced in gypsum, salts, and cavity conditions. Otherwise, he will dissolve all the subsurface soil and create hazards and subsidence. So technique of soil improvement, I don't need to talk too much about. You know it all, you are a specialist. But here, for example, I a little bit talk about the deep mixing application, which I used, for example, for certain projects. This, for example, tool of deep mixing, either soil mixing or, for example, jet grouting, or what we can say, jet grouting, soil mixing, okay, or controlled modulus column, are proved that they are efficient techniques for upgrading the problem, or for overcoming the problem, and provide, for example, suitable, adequate, durable kind of foundation. And other, for example, normal technique are not recommended at all for this kind of materials, like, for example, dynamic compaction, dynamic replacement, rapid impact compaction, even vibro replacement are not recommended at all for this kind of materials, because in a lot of, in more than one site, for example, all these techniques failed to, for example, to support safely the structure, and the structure and infrastructure with time, for example, have subsidence, cracks, collapse, etc. Which kind of binder they are using? There are a lot of binding materials, for example, used, but the most adequate one is the cementitious binder, and there are some researches proving this one, and we did some projects using the cementitious materials, and we did, for example, what we can say, durability test on the subsurface soil. Some people saying which kind of durability test you do. This is, for example, taking a samples after treatment and before treatment and make the comparison, doing drying, for example, wetting cycles of harshing conditions in the lab as per, I think, ASTM, yes, ASTM D559. And I think you can measure the durability of the loss of the materials. The cementitious material, for example, is a good material for the deep soil mixing and the jet grouting. This is some of, for example, researchers doing some research on the soil parameters by adding, for example, 2.55, 7.5, 10% of cement on the materials to mix them, for example, and measure the normal soil parameters like angle of internal friction, like, for example, cohesion, modulus of elasticity, etc. You can read it for more information. And the durability test, this, for example, rarely known by even laboratory and specialists on the treated soil. I recommend that you refer to this and read it for more information. And for example, Zhang and 2008 for silty and soil, like the one used in the investigation, they told that a maximum loss of material can be up to 14% is okay. If more, for example, the soil can be considered as, for example, hazards. See here, for example, the treatment with cement using the microscope before and after. It's clear, for example, the improvement of the soil particles with the cementitious material. Now, as a conclusion, I can say or can ask, for example, if you agree with me that the geotechnical engineering is 50% judgment, yani meaning need an expert using, for example, his sense also, in addition to the testing results, to understand the geotechnical behavior. And also, like a question, if you accept as engineer the extreme solutions. Why I ask this question? If you see, for example, or you saw, for example, the solution implemented for the service road, when they, for example, fix the soil hazards by using piles everywhere and slab on piles. If we go for this, for example, solution, where is the role of the geotechnical engineering? And also, whether, for example, we can rely on the soil replacement rather going, for example, to the extreme, using, for example, jet grouting or soil mixing techniques. By the way, I would like to add something very important, that, for example, some of the projects They told we will use, for example, TAM grouting, tuba manchette grouting. But the tuba manchette grouting, for example, one of the clients asking me for a strategic project, how much, for example, you give it, for example, on 10. I told him even one I cannot give. He told why? I told this technique filling voids, but the soil hazards, for example, meaning with time we will have more voids because the soil will dissolve and create more voids and more hazards. He told me that's exactly what happened with us, for example, when we use this technique to fix, for example, the gates of this, for example, infrastructure strategic project. After certain time, the doors again, for example, or the gates again, for example, settle using this, for example, tuba manchette. Also, as a question, I'm asking whether, for example, you accept that geotechnical solution to be replaced by structural, like what, for example, used in the road, for example, piles and slab, and this solution is very expensive. If yes, the question, tell me what shall we tell to scientists and researchers working in geotechnicals from decades? Finally, the geotechnical engineering is an art, and not anyone can be a geotechnical artist. So I think most of you maybe agree with me in these conclusions. Thank you very much. If you have any question, we can answer the question. And I think we finish at time, but we took 10 minutes more than what Engineer Hamza allocate us. Thank you very much.
Thank you, Dr. Muhammad, for this detailed presentation indeed. And I do agree with you that geotechnical engineering is indeed an art and judgment. I think maybe more than 50% even.
Yeah, thank you very much.
Yeah. We have actually a couple of questions or many questions. I would start with Waleed. He said, what is the typical laboratory test to identify high presence of calcium carbonate, and how to identify the high cementation?
Yeah, this he has to, for example, first of all, assign, let's say, not an expert geologist, rather a geologist with certain, for example, understanding about the soil sample description during the drilling and also in the labs once they receive the samples. How, for example, to describe, how to identify the nature of the material, and then, for example, take the samples and prescribe the type of tests to be done in this kind of materials. Or, for example, if the geologist or the engineer in the lab working as a commerçant, that meaning okay, I have, for example, for this project specified by the consultant this. So he will not, for example, make a headache to himself and do this test. The engineer, meaning the consultant, shall prescribe at the time of, for example, request for proposal to do this kind of investigation from his experience in this area, in referring to other similar projects in this area, prescribing the type of testing to be done. Like, for example, I need carbonate at this level, at this level, at this level, or at this depth, at this depth. I need, for example, organic matter. I need, for example, Atterberg limits. I need, etc., etc. So he prescribed this, and he can, for example, identify this kind of materials. But unfortunately, 1,000 times that most of the laboratory are not care about this and not bringing the attention of the engineer to these hazards. Yes, just yesterday, with one of the colleague, we opened two reports. The report around 1,700 pages. And you are talking about hundreds of boreholes. You only they did, for example, two sample as carbonate test. Two sample. Yani they have hundreds of boreholes, and the SBT somehow, for example, 0, 1, 2, 3, etc. And he didn't make, for example, some effort and say, okay, we'll do some tests to identify this. Why? Because the engineer who prepared the specification and who, for example, asked for this investigation, he didn't prescribe this kind of tests. So at the end, it's the responsibility of the engineering firms or the engineer doing for example, the design for this projects. Why, for example, this shortening in doing this proper works? As I told in my presentation, that the majority of engineering firms, they don't have a geotechnical specialist. And the civil and structural engineers, unfortunately, replace the role of the geotechnical engineers and saying, okay, we understand the geotechnical. What's the geotechnical? Soil mechanics, finish. We will recommend this, and we need bearing capacity at the end. And this is the responsibility of the lab, for example, if there is a problem for example, the foundation design or something like this. I hope that I answered this question.
Yes, for sure. And another, I think, comment or question from Abdurrahman, he said the pH value can be used to determine the presence of calcium carbonate in calcareous soil. So is it?
BH?
Yes.
No, cannot. pH cannot. No, never, ever. No. You have to do
Okay.
carbonate content. You have to do, for example, gypsum content. You have to do TSS, total soil solvable, the TDS, for example, dissolved the salts, etc. No, you cannot. pH, no. pH, by the way, pH and chloride and sulfate for the concrete durability, not for the soil durability. I told you, no one, for example, care about the durability of the soil. This is the problem.
Indeed. Okay, and another one from Sama, asking about which areas of the UAE with these deposits are more, based on your experience.
I think this, for example, exists all around in most of the areas. And one day I made a presentation for a governmental entity. They asked me, from where you bring this information? I told them from Uncle Google. Go to Google and you will see that all this information published there. For the Gash Saram information, formation, etc., everywhere. So the hazards everywhere. So why you for example make for example wrong decision in doing, for example, the design, and they didn't pay attention to this kind of materials. So there are, for example, papers published in international journal, etc., and book, all, for example, talking about this. This is not only in UAE, by the way. This is in Oman and Kuwait and Saudi Arabia, everywhere.
Okay, we have also another question from Nabaz, and he's asking how we decide on the depth of the deep foundation. Shall we penetrate this hazardous layer, or we can stop within this layer?
The depth of foundation or depth of treatment?
No, the treatment, like piles or CMC. Or...
The treatment. Well, this is really a very good question, or even an excellent question. I have as a strategic, or I had a strategic project where I told you that I didn't, for example, do any kind of soil investigation because they told me 5 days. What I will do in 5 days? And they need in 2 months to finish everything. And you are talking about thousands of square meters. So in this case, for example, really, I relied on the judgment. As you told Engineer Hamza, more than 50%, I relied on the judgment. So even the contractor appointed for doing the, for example, the soil treatment, his machines, for example, without any computers, like for example 1990 1960 years old, or more than 50 years old, their machines. And we don't have other option. For example, we have to experience. So in doing, for example, the improvement, for example, up to 10 meter in this point, the client saying, why you are doing this 10 meter? There is something between you and the contractor. You need to increase, for example, the amount to be spent on this. Listen, my dear, bring the drilling machine and the drill here. And so after proving him with from my experience that here we need 10 meter, because like I'm driving a car, when there is, for example, a slope, when I use, for example, the acceleration, when I use for example, the moment, etc., something like this, I told him, same as you are driving a car, the operator, he knows where there is hard strata, where is there, for example, a weak strata. Then in bringing the machine, they drill, they found the same what I told them. So the engineer in this case, judgment is very, very, very important. Because in doing the drilling, he will also investigate the overflowing materials, and he knows that there is something hazards underneath. Yeah.
Interesting. Thank you, Dr. Mohammed. Another question from Shafi. He said if we can use the geophysical survey to determine the gypsum or carbonated soil, and what kind of tests, if we can use them.
I think yes, MASW and electrical resistivity test, I think widely used, and they can, for example, identify this kind of materials because based on their experience and the calibration boreholes done for other, for example, site, they can, for example, from the resistivity and the shear wave velocity, etc., saying that whether this hazardous material or not. And even, for example, they ask to do some calibration boreholes to ascertain the findings from the geophysical survey. Yes, we can always rely on the geophysical and the geophysical proof with time that, for example, had a good results. And these results, for example, confirmed by the calibration boreholes or other kind of tests.
Okay. Another interesting question. I'm sure many designers have thought about this question from Zahir. He said if there are any equations that incorporating already the effect of the gypsum and carbonate on the bearing capacity, and if there is a software can deal with that.
I think I answered this question during the presentation. Unfortunately, no relationship up to date, no software up to date, and we have to rely on the judgment and also the testing, the chemical testing, saying that the presence of this, the percentage of this, so and so and so. Then, for example, you have to do some mechanical, physical improvement. And then, for example, we can rely on the softwares doing the modeling, and the structure subburst or infrastructure will be supported in this, let's say, artificial elements embedded into the soil, which is the columns created by jetty grouting or soil mixing or etc.
Another question from Dr. Mubashir from KQBM. He said, with the recent development of artificial intelligence and machine learning in geotechnical engineering, he thinks that the identification and prevention of geohazards is becoming more scientific rather than an art. I think this is Dr. Muhammad, is a recent trend indeed going on. And for example, where I work at GeoFilm, we are already using the INSAR remote sensing to develop susceptibility analysis and prevention and early signs monitoring based on the artificial intelligence and machine learning. So what do you think, Dr. Muhammad?
Yeah, I think you are right, but this need a lot of the database, because the artificial intelligence at the end, for example, something or deep learning, something programmed by the human. If the database for the human are, for example, not enough, for example, insufficient, the artificial intelligence will give you, for example, wrong results. So still the artificial intelligence not reaching, for example, the level of brain and the level of, for example, human to make the judgment. If now, for example, chat GPT, for example, anyone now everywhere is using this tool, for example, to get some text, something, etc. I tried many times, for example, to get something. What is answering me? Is answering me that I'm an AI. I don't have, for example, database for this. I cannot answer you.
It has a limitation, of course.
And also we are calling, for example, for example, data center like telecommunication companies, etc. They put, for example, an AI, for example, robot to answer us. I need, for example, to talk with a technician. No, not answering. I'm, for example, trying to do this, to do that. Still, the AI not reaching the level, for example, of reliance to, for example, to rely on it and its interpretation, unless we have a wide, for example, research and a wide database, for example, for certain area to, for example, rely on its results.
Maybe this is something we can try, Dr. Muhammad, together with
We tried
some case
the research
studies,
will
and
continue.
maybe maybe we can show it in our
Agreed. I
presentation.
told you you need يعني a big database يعني for this.
Yeah.
Yeah.
There is another question from Abdurrahman. He's saying there is a test with the vinegar, white vinegar with acidity of 5% to test the calcareous content. If I think he's asking.
The test what?
White vinegar.
White vinegar. I didn't hear about it, but we can يعني search about it and provide the
الخل
answer.
هو
Or he can, for example, yeah.
باستخدام الخل.
الخل, yes, yeah, الخل, yes, يعني but I told you يعني we didn't try it يعني not familiar with this. Even in the laboratory they are not using this. This is يعني let's say, for example, in-house maybe test يعني, but not to prove it, not publish it يعني.
Yeah. Another also technical question from Zahir. He said the consolidation is the best test to determine the properties for this type of soil.
No, cannot consolidation, because you have lots of material. Not for example, consolidation done, for example,
Mechanical.
on mechanical, for example, where you have water, you have voids, you have air. But here, this is the material itself, the particles themselves, for example, the solve. Or loss of the material, yani. So the particles will, for example, move from their position, look, for example, for other stable position, creating voids, etc. So consolidation cannot identify this kind of materials. I told you this kind of materials, ASTM, I think I mentioned the number 5 something, talking about the durability of these materials, and meaning exposing the soil to harshing conditions, and measure, for example, the loss of volume and weight of these materials. This is what we can, for example, do in this kind of test, in addition to the chemical test. But doing consolidation, no.
Another interesting question also from Imran, saying, is there any swelling or collapse potential associated with the GeoCS soil?
No swelling for this soil, no swelling, no. Always, for example, settlement, because you have loss of volume, loss of weight, you know. But swelling, this is not the clay for sure, you know, or silt. Okay.
This- also, he's asking about one of the case studies you have presented, that how you achieved the conclusion it is resulted from the gypsous soils, why it couldn't be contributed to poor workmanship or poor compaction.
This always, we had a discussion, I think, even on LinkedIn with many specialists regarding, I don't know, maybe you were part of this discussion, saying that, okay, this is, for example, poor manship, or this is poor compaction also. No, the experience and also the test proof that, for example, for many sites, they did, for example, very proper compaction using also suitable material, but after certain time, this material loosened and becoming worse, and couldn't, for example, fix the problem by replacing 1 time, 2 times, 3 times, etc. So the problem coming from the evaporite materials in circulated by the water into or the water, for example, evaporation in between the soil particles, and for example, weaken the links between the soil particles and loosening the soil and creating voids. So we cannot say the man workshop, neither, for example, the poor compaction. And because no one as contractor or consultant prefer to reach this level of damage. By doing a little bit effort, he will, for example, achieve the relative density specified in the project specification. But the problem, unfortunately, is not the case. The problem is from the, as we told, the parent formation and the evaporite materials. Yes.
Okay, thank you, Dr. Mohammed. I think we are reaching the time now. It's 2:30 and 3:30 at your time. So if anyone has a question, please feel free to unmute yourself and ask it. Or if you have any suggestion for the next GeoTalk, please do let us know.
Assalamu alaikum, Dr. Mohammed.
Wa alaikum assalam wa rahmatullahi wa barakatuh.
It's Hamza, your ex-colleague. It's good to hear you after 10 years. If you still can remember me.
Where we were?
Thank you.
In ACTS Qatar.
Yes, I remember. Hamza, you are in Singapore. Mashallah.
Yes, how are you?
Yeah.
Can I have your contact number?
I think in the presentation, yes, I can, and even I can send here, for example, in the chat.
You can give to Hamza Marwan. I will take from him.
Yeah. I will give everything to Hamza. I cannot hide anything from Hamza.
We will share, inshallah, for all the presentation and contacts for everyone.
Okay,
I'm happy to hear
see you
from
later.
you, yeah, mashallah. Still in Singapore?
No, I'm back in Qatar now.
Welcome back.
Thank you.
Thank you. Yeah, I send my email and my phone number in the chat. Yeah,
Okay,
and I will share
thank you so
this
much.
presentation also, inshallah. Okay.
Thank you, so nice of you. Thanks.
Thank you, Engineer Hamza. Thank you. Yeah, I would like to thank again Engineer Hamza Al-Hashmi for the big efforts he's doing for this GeoTalks. And I'm happy to contribute